record. Okay. All right. So yesterday, this was the homework. There was only one other problem, and then there was this one. Okay. And this is going to help us really understand the first of 2-ish, 3 problems that we have to do in the notes, and then we'll go to the homework. Okay. So I love this problem because it really makes us make sure we understand rational expressions. And I think by the end of today, if you've been here all week and you've been understanding what we've been doing, you're going to be like, okay, I get it. I understand rational functions already, okay? We still have one more day of it, though. And don't forget your quiz is open. You have until Tuesday night to do it. So if you want to get that done this weekend, okay, but you still have Tuesday up until midnight. Okay, so when I look at this graph and I want to write the equation of it, the function, I'm going to pull all the information off of this that's important. Same stuff that we pull out of the equation to graph. So things like asymptotes. And the asymptotes aren't marked on here. And sometimes they give like the little dotted lines, like how we graph them. And sometimes we have to find them, okay? And so what you should look at, like let's look at the vertical one. You should be able to tell by what the end of your branch is doing here and here. It's already crossed over the 1. It's probably easier if you look at your own versus mine. But you already crossed over the 1. So we are getting really, really close to 2. See how we already crossed over the 1, but we haven't yet crossed the 2? You can safely assume that that is your vertical asymptote, okay? Same idea for the horizontal asymptote. At first glance, you might think it's 0, but then you're like, wait a second, I already crossed 0. What's the other number I'm getting close to? It's 1, yeah. So y equals 1. All right, in the homework, they're marked for you, so you don't have to do that, but it's a good skill to be able to kind of see. All right, I see a hole at 3, 7. Okay, right, 3 up 7. And x-intercept. I see an x-intercept. Pretty sure it's right there, okay? Now, you could pull off the y-intercept, and if you look at my key for the homework, just getting ahead to tell you that, I wrote the y-intercept, but you don't really need it. If you pull it out, it's not going to hurt anything, but it does not help us get our function, so I'm not going to even bother with it, okay? But it is negative, too. All right, so let's go through and answer the questions. So starting with, what can be determined about the degree of the numerator compared to the degree of the denominator? Okay, so does anybody know? What does this tell us? What do we know about the degree of the numerator and the degree of the denominator? Simply by the information I pulled out. Anybody know? What? Same degree. Okay, so I'm going to sum that up a little bit, and you're exactly right. Let me explain why, in case you didn't know. Okay, so just a quick review of horizontal asymptotes. If the top is smaller than the bottom, because remember, we look at the degrees of the asymptotes, the degrees of the numerator and denominator to determine our HA. Whenever that happens, it's going to be y equals 0. Okay, so less on top than the bottom, whatever the numbers are. If it's less on top and bottom, it's going to be 0. Okay, we didn't get 0. If you have bigger number on top than the bottom, you say there is none. And then you could go and find the slant asymptote if you needed to. We won't need to for any of this. And then the other one is if they're the same. Then you could get y equals really any number except 0. It's whatever the a over b is, right? So whatever the leading coefficients are on top and bottom, that's your a and that's your b. So here's the moral of the story. When you have an HA that's not 0 and not none, so anything other than these two, anything other than that, you know your degree should be the same, okay? So that's where she got that. So they are the degree of, and I'm really abbreviating here, numerator equals degree of denominator, because y equals 1, not 0, not none, okay? So if a and b represent the ratio of the leading coefficient of the numerator and the leading coefficient of the denominator, what is the value of a over b? So if y equals a over b, what is the value of a over b? What is it? Imelda, you know. What's the value of A over B? 1, right? That's all it's saying. When you do this over this, 1 over 1, you'd get 1. 2 over 2, 3 over 3, that's what does it equal? They must be the same number in front as well to be able to get 1, okay? All right, what factor is guaranteed to be in the numerator? Okay, factor, numerator, does not cancel. What's another word for that or term for that? Come on, guys. I just told you you were my favorite class. Who said it? Where was that? Who said that? You said it? X-intercept. How is that hard? Okay. Remember, if you are an X value left in the numerator, meaning you didn't get canceled, you are an X-intercept. So, what factor is guaranteed? Okay, so because the X-intercept equals -4, the factor it left in the numerator, factor is what? X plus 4. Remember, just like if I give it to you in factored form and ask for the 0 or X-intercept, you set it equal to 0 and solve. Other way around is the same. If I give you the 0, you have to bring it to the other side. Did everybody get enough? You want that? Everybody? You guys enough? You guys? Okay. Trying to be funny. Did you guys okay? Make sense? Doesn't get canceled. What factors are guaranteed to be in the denominator? So when we look at our denominator, what do we get from our denominator? We get wholes and VAs, right? Everything that, those two numbers that cause a problem. So we have a VA of X equals 2. In the denominator, it would be X minus 2, right? We have a whole at X equals 3. In the denominator, it's X minus 3. We don't need the 7 for anything, right? We find that 7 by plugging the 3 in, but we don't need to do that. Okay, so those are both in the denominator. Two more. What factor is guaranteed to be in both the numerator and the denominator? Which one? Right, so which one? X minus 3, because it's really the X value of the whole, but whatever. So remember, X minus 3 is in the denominator. It must be in the numerator too, because by canceling it, it becomes a whole. And what factor is guaranteed to be in the denominator and does not cancel? The VA, right? And so that's the X minus 2. All right, so let's go back up to the top and put it all together and make sense of this. And then we'll go to another example in today's notes where we don't have to answer all the questions. We just kind of throw it in there. All right, so let's go back up. So it says that R of X is our function. We know it's going to have a numerator and a denominator, which is the definition of a rational function. I like starting with the denominator. You start with whatever you want. So vertical asymptote comes from my denominator and wholes, right? If you're a whole, you must have canceled with the same thing in the numerator. So I know I have to put one of those in the numerator. And then all that should be left for our numerator is the X-intercept. That's what's left after you cancel anything out with the denominator. Okay, Stephen, you paying attention? Okay, now, before we walk away, let's look at the HA. There must be there is another reason that we have that. Because sometimes, let me back up. This is X squared on top, two X's in the bottom. Just like Imelda said, it would be same on top, same on bottom. And there would be a 1 in front of these. So y equals 1 makes sense. But if this was like y equals 3, for example, we would need to add something to this because we would need like 3 over 1 or 9 over 3 or something to make a 3 in the front. And we're going to have one of those in our homework that I'm going to do with you. But just so you know, in case you start tuning me out, per 10, this was a 3 here, y equals 3. I still know what that means. It means I should have the same numerator degree and denominator degree. So we already have that. All I would have had to do is put a 3 right here, and it would have made it exactly what we needed. Okay, and you'll see that when we do it. This is factored form. We're going to have to put it in standard form as well. And I'm just going to give you the answer, but I always like to ask at the beginning of the year, is there anyone that doesn't know what foiling is? Because some schools up north, I have learned in all my years, some schools up north don't really call it foiling. So I just want to make sure you guys know how I got that. I did x times x times -3, 4 times x, 4 times -3, and combine the two middle terms. Is that bringing a memory back to you guys? Do we know that? Yes? Is there anybody that doesn't? Because I will do it right now. If you don't and you just don't want to say it, make sure you call me to your desk later, because you do need to know how to multiply two binomials together, called foiling. Factored form, standard form. Okay? Question before we go to the next one? Find it. I know we're gotta go all over the place. Same idea, new graph, don't have to answer any questions. We just need to put it in the correct format. Okay? So let's pull some info off of the graph. All the same important things. VA and HA are a great start. Okay, so vertical asymptotes, you can see them. They're dotted there for us, nice and easy. X is 2 and X is -2, right? We have two vertical asymptotes in that one. Horizontal asymptote isn't marked, but by the behavior of those two end branches, we should be able to tell what it is. And something to remember, and we just learned about this graph yesterday, but when you split your graph into 1, 2, 3 vertical sections, you do have a horizontal asymptote. Sometimes it's at 0 like this one, sometimes it's up, sometimes it's down, but there is one there, and it is at y equals 0, which is the x-axis, okay, because you can see these branches getting really close. Remember, that middle one will sometimes cross the horizontal asymptote, which goes against everything you've been taught, but that is, it is allowed, okay? All right, there's no hole. I scanned it. I don't see a hole anywhere. The only other thing I could get out of this would be an x-intercept right there, which is 0. Okay, let's go. Call it whatever you want, f of x, g of x, y. I don't care. Make a fraction. And again, I like to start with the denominator. I have vertical asymptotes, 2 of them. They both go to the denominator. So x plus 2, x minus 2, in order, of course. If there was a hole, I would add that one in there too. But I don't have a hole. So that's my denominator, okay? My numerator has an x-intercept of 0. Now, when I have an x-intercept of like 3, I know how to make that a factor. I have x equals 3, I subtract 3, and I go like this, right? How do you change a 0 of 0 to a factor? I guess I could subtract 0 and get this, but I could put a plus as well, because zeros don't really have a sign. We don't really write x plus 0 or x minus 0. What? Not plus or minus, because that's if we do the square root, but did somebody else say? What? Don't overthink it. What would we have on right here that would tell us we have a 0 of 0? Just x. Just x. If I said, what is your x-intercept, you'd go, I don't, what? I'd say set that equal to 0 and solve it. Well, you set it equal to 0 and solve it, it's already solved. X equals 0, okay? So we just leave it as x. But here's the problem. Well, I'll tell you the problem in a second. One last thing, always check your asymptote. See if it makes sense. So we have a horizontal asymptote of y equals 0, which means the top should be less than the bottom. And it is, right? We have 1 on top and 2 on the bottom. So that's good. But here's the problem. It's the only time this ever happens. when you have a single x on your numerator, no other, there's not a whole or anything else, we could have possibly lost the negative. Because let me just explain to you, whether I have x equals 0 versus negative x equals 0, when I solve both of them, I still just get 0. Because when I divide by a negative, I can't get a negative 0. So how do I know that this is an x or a negative x? You don't know just at this moment. Okay? Why does it matter here and not on any others? Well, just use this as an example. When you have x minus 3 on top, I'm very clear on what the signs are, right? The 3 is negative. When I solve it, it's positive. But for this reason, your x could be positive or negative. So this is the only time you're going to have to do this. Pick a point on your graph. Any point on here, any point here, here, here. I like just using something nice and easy like 1. So x is 1 right here. So what I'm going to do is plug 1 in for every x, and I'm going to see what I get. I don't really care what the answer is, except I know that the y value at this point should be what? Positive or negative. What should it be? At x equals 1. It should be positive. So if I get a positive whatever here, who cares what it is, I know I have this right. If I don't, I know I have it wrong, and I need to include the negative. Let me show you. So I get 3 times negative 1, which is negative 1/3. That's bad news. Something's wrong. I should have gotten a y value that's positive. So all you have to do is make that a negative. And all that's going to do is make my 1 negative on top. The bottom would still be the same. It would be negative 3, sorry. So that gives me a positive 1/3. The only time you have to worry about that is when the only factor in your numerator is a 0. Actually, anytime you just have an x by itself, I should say, you would have to do that. 99% of the time, that never happens. I just want to make sure you kind of think about these things, okay? When we get to the homework, this is one of the 2 types that you'll do in the homework. I'll do the first one with you to kind of do another one with you in the homework, okay? Turn the page, and we are going to do something called the binomial theorem. Half of this you probably might remember from Algebra 2, okay? But don't worry, if you don't, I'm going to reteach it to you. So this is kind of confusing, so kind of listen. What we're getting to is this. I'm leading us to this final example, which is not hard, okay? There are 2 ways to do the first part of this type of problem. What I'm showing you here is 1, 2 ways, okay? So you don't know why we're doing this right now. Just trust me. We'll get to it, okay? And so what the binomial theorem is a way for us to do a binomial to any power. We just did, we just multiplied 2 together. Like, this would be really easy for you guys to do by hand. There's the shortcut, or you could write it twice and FOIL it, right? Even x minus 1 to the 3rd power isn't too bad. But what if I said do x minus 1 to the 5th power? Or really complicate it, 2x minus 3y to the 5th power, okay? This theorem lets us write it in standard form with a little method, okay? So that's what this is about. This first one part is probably new to you unless you took Prob and Stats or AP Stats. I don't know. Nobody has said they heard of it before. And then we'll talk about Pascal's triangle, and then we'll put them together. But just for now, I'm going to teach you about n over r, also read as n above r. We'll talk about where you get what it does. But here's the breakdown of it. Look how fun this is. Did you know there are exclamation points in math symbols? That's so cool. So n over r, we rewrite it, expand it, if you will, like this. That exclamation point in math means this word called factorial. Okay? So let me just read this to you. N over r equals n factorial over r factorial times the difference of n and r factorial. Okay? So we're going to expand these 3 together by hand easy. And then I'll show you how to do it on the calculator. Easy. Okay? You just never know. Are you going to have a calculator if you get a problem like this, or are you going to be expected to know how to do it by hand? Okay? So here we go. The top number would be your n, so I'm going to start with that. So that would be 6 factorial. And I know you don't know what that means yet. We're going to get to it. Over the bottom number, factorial, times the two numbers subtracted, factorial. Now, that's the last time we ever need to write it like that. We can go right to 6 factorial over 2 factorial times 4 factorial. Okay? So you don't have to write both steps. Factorial, really, really easy. The numerator, 6 factorial, would look like this. 6 times 5 times 4 times 3 times 2 times 1. Whatever number they give you factorial, you start with that one, you go all the way down to 1, you always end at 1. There's no fractions, there's no decimals, there's no negatives, there's no 0. Okay? On the bottom, 2 factorial. 2 times 1. Short ride there. And then 4 factorial times 4 times 3 times 2 times 1. Okay? So doing it by hand is actually writing all of that out. And then you could use your algebra skills and kind of start simplifying it, right? 4 over 4 would cancel, 3 over 3, 2 over 2, 1 over 1. You're left with 30 over 2, which equals 15. So the final answer is 15. Okay, not hard, kind of annoying, but not hard. Okay, let's do another one, and I'll show you a little shortcut here. So 9 over 4 would be 9 factorial over 4 factorial times the difference, 9 minus 4, is 5 factorial. Now, instead of writing 9 all the way down to 1, do a quick glance at your denominator, and maybe that will help you understand what I'm going to do here. 9 times 8 times 7 times 6 times 5 factorial. Wait for it. 4 times 3 times 2 times 1 times 5 factorial. What I did is I stopped my numerator at the biggest number in my denominator. Because really, do I need to write out 5, 4, 3, 2, 1, 5, 4, 3, 2, 1, and then cancel them like I did here? I could have stopped at 4 factorial, because that's what that means. This means 4 factorial. This means 4 factorial. So they cancel. So those cancel. And you're still left with yuck. And you could simplify some of this. I would tell you to pick up your calculator and do it. But you could do it by hand if you had to. Okay? You should get 126. I'll show you how to put it in the calculator in a second. Good so far? Easy, right? This last one, there's a fact I need to tell you. Anytime you have 0 factorial, it equals 1. And you should be able to remember that because like anything to the 0 power is 1, 5 to the 0 power 1, x to the 0 power 1. 0 factorial is 1. So 3 factorial over 3 factorial over, or times 0 factorial, subtracting them. So 3 factorials cancel. That leaves us with just a 1 on top, and 0 factorial is 1. So the answer is 1. Moral of the story, anytime you have the same number on top and bottom, it's always going to be 1. Okay? That does not mean 6 over 2 would equal 3. I just proved to you it doesn't, okay? So it's just that one. Okay? Let me show you on the calculator how to do these. So I'm going to show you where 2 buttons are. First, I'll show you where the factorial button is. So if you were just needing to find what is 3 factorial, and I think these are on the SAT, so this is kind of helpful and timely. So 0 factorial, you would want to put 0 on your screen first. So you type 0. And then math, your math button. And then go across the top, use your arrow button to PRB, which is probability. So go to that menu, and if you look down, number 4 has your fun little factorial button. So if I press 4, it goes back to your main screen, you have 0 factorial, and you hit enter. So you can, I just proved to you 0 factorial is 1. okay? But we don't want to do these in parts. I want to put the whole thing in my calculator, one swipe, and get the answer. And we can do that using this symbol right here, NCR. So same idea. Let's do 6 over 2. You start with 6. You got to put the 6 on there first. And then we want the NCR symbol. It's in the same place. Go to Math, over to Probability, and it's number 3. See, number 3 is NCR. It goes back to your home screen. 6 NCR 2. Enter, we get 15. 9 over 4, I would put 9 on here first. Math, Probability, 3, 4. Okay? So if you missed any of the steps, you're having problems, please ask me when I'm done. I have one last problem to do. Okay? For the most part, did we get that? Did you need help? Did you get that? All right. So I'm going to just ask that you hold on to the knowledge I just gave you about N over R. There are 2 ways, as I said, to start these problems. This is my least favorite way. So I'm not even going to talk about it today because I'm going to give you the easier way, which is called Pascal's triangle. So you might say, why did I cover that? Because we could have a problem where it just asks for something over something, like one of these types of problems. And I needed to introduce factorials to you. Next week, I'll kind of tell you, if you don't like Pascal's triangle, you could do this, but this is much easier, okay? So Pascal's triangle, you may have heard of it before. Some guy named Pascal, however many 100 years ago, somehow came up with a way to find the coefficients when you expand one of these. When you expand those, the numbers that go in front, these have to be there. And he came up with this really easy way of doing it. So we're going to practice a few times together, making this triangle. This is something you should be able to create on your own. And it's simple. You start with 1 and then 2 ones. It's like the top of a triangle. Okay? Then you start adding. What can I add? There's only a 1 plus 1. I'm going to add those 2 together and get 2. You put it right in the middle. Since there's nothing left to add, I'll put 1s on the outside. We're always going to put 1s on the outside. And I just start adding again. So I'll just go left to right. 1 plus 2 is 3. And put that in between 1 and 2. 2 plus 1 is 3. 1's on the outside. And this goes on forever. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1's on the outside. Now, I'm not going to make us go any further, but you could definitely make the next row. It would be 1, 5, 10, 5, 1. So do we get that? We'll practice it again in the homework. I'll do one of these with you too. This is all we need to expand, well, not all we need, but we need this as our first step to expand x minus 2 to the 3rd power. So this is taking x minus 2 3 times and multiplying it out, but using a different method. So what we want is to grab the row that has 3's in it. There's only going to be one row that has 3's in it. And just grab those numbers and put them in your little space so you know what numbers you're working with, okay? And these are going to lead the way. I'm going to start with the first number and write 1, okay? That's this one. And I'm going to start with the first term, which is x, and I like to use parentheses, and you do it to the power of 3. Okay? So just stay with me. It takes me a couple of these to go into before you start seeing a pattern. Just stay with me for 1 second. The next one would be a 3. So I'm going to put a plus sign. Notice I didn't do anything with the -2 in the very beginning. I didn't touch it. Okay? Then I put a plus sign. That's this 3 right here. I'm going to put the x again, and we're going to count down. So this is 3. This would be 2. Here is where we're also going to introduce the other term, which is -2. It's the first time we're seeing it. We'll put a 1 on it. Now, let me explain something to you. Your exponents should always add up to this number. So 2 plus 1 is 3. This is 3. Why didn't I put a -2 in with the blue? It's there, but it's got a 0 as its power. -2 to the 0 power is just 1. So why write it, all right? And I'll come back to that idea as we finish this. Next one is a 3. So I'm going to put that next. X again, and we're counting down. I have 3, 2, 1. Then I have the negative 2. I'm building up. 0, 1, 2. Do my exponents add up to 3? Yes. One more. 1. Now, I ran out of x's. I could put x to the 0 power, but that's just going to equal 1 anyway. So let's not write it. We just have one last negative 2, which would be power of what? 3. Notice none of my exponents are bigger than 3. That will help you because sometimes I've seen students go like 3, 4. They're like, wait, I forgot. Do I go down or do I go up? But you're never going to go bigger than this number. So that should prevent you from thinking you would go 3, 4. Okay? All of the numbers are less than 3. 3 or below. Now we just write the final answer. So this would simplify to just x to the 3rd, right? In the red, I have 3 times negative 2, the first power, so that's negative 2, is negative 6, x squared. Green, negative 2 to the second power is 4. 3 times 4 is positive 12, and we have x to the first. Right? 3 times 4 is 12, x to the first. And last one, negative 2 to the third power is negative 8, times 1 is negative 8. That would be your final answer. Notice a couple things. It goes positive, negative, positive, negative. If there's a negative in here, it will always do that. It'll always go back and forth. So you can't mess up on your signs because you can fix it right there. Also, look at the pattern in your powers. 3, 2, 1, 0. Okay? And we'll do another one of those in the homework right now, in a minute. Okay? Question before we go to the homework together? Okay. That's not in homework. Paper. It's find that. Okay, so 92? That's page 92? 94. Okay, so let's start pulling the information out of the start pulling out anything that looks important in number 9. Okay? So asymptotes. So that would be a VA. Right? We have a horizontal asymptote at y equals 2. Any holes? No. That's a point. It's not open. I think whoever created this wanted us to make sure we saw that that was an x-intercept. And that's all we have, right? There's no hole. We don't worry about y-intercept. Good? That's all we need. Right? Call it what you want. I like to start with the denominator. So VAs come from the denominator. So x equals negative 2 would become x plus 2 in the denominator, right? There's only one VA, and there's no hole. So nobody else goes in the denominator. That's all we should have in the denominator, VAs and holes. So that's it for the denominator, okay? The x-intercept is 3. That's going to go to the numerator, right? Before it was a 3, it was an x minus 3. Now, let's look at our HA. Remember, don't forget about checking with that. So far, I see I have a degree 1 over a degree 1, okay? But it says this should be a 2. What is my A over B right now? The way I have it. 1. Look, if you blink, you'll miss it. I want it to be a 2. It's a 2. Now it's 2 over 1. Why does that work? there's your factored form. I'm going to go ahead and distribute the top to give us our standard form, okay? These are the answers, but let me just show it to you in reverse. If I said, what's the x-intercept of this graph? You go, oh, I know. I set my numerator equal to 0 and solve it. So I add 6, divide by 2. I still get that x-intercept, okay? It's perfectly fine, but it changed my HA. Yeah. Okay? So that's why this is so important. If it said 1, we would have been done, okay? We wouldn't have had to do any of that. But since it was a 2, I had to make it a 2. I made it a 2. Look, 2 over 1. Okay? I'm going to do number 13 with you too. So if you want to do that with me. Can't find any of this stuff. What is 13? X plus 1 to the what? Okay. Okay, so Pascal's triangle practice again, if you need it. You make your ones and then start adding. So 1, 1, 1. Add. 1's on the outside. 1 plus 2. 2 plus 1. 1's on the outside. 1 plus 3. 3 plus 3. 3 plus 1. 1's on the outside. And that's as far as I need to go. I find the row that has the 4's in it. There's what I needed from Pascal's triangle. Okay? So same pattern. Start with 1. And then the first term to whatever the power is. And you could put 1 here, but it would be to the 0 power. Okay? So I don't add it in. The next one is a 4. Do I go up to 5? No, she said I'll never have a number bigger than 4. That means I must go down. And this is where I introduce 1 to the first. Adds up to 4. Next one, 6. X to the 4, 3, 2. 1 to the 0, 1, 2. Adds up to 4. It's all about patterns. Almost there. 4 to the x to the 4th, 3rd, 2nd, 1st. 1 to the 0, 1, 2, 3. Exponents add up to 4. Last one, x to the 4, 3, 2, 1, 0. I don't need to write it, but I can put the 1 to the 4th. Yes. Okay. So if you guys want to go ahead and simplify that, I'm going to explain. Let me just simplify it real quick. So this would be x to the 4th. These are easy when there's a 1 here, okay? Because it's 4 times 1. Notice they're all positive. They should be. Notice the exponents are descending the whole time. You can see that pattern. 4, 3, 2, 1, none. That would be your final answer. Okay, Imelda, I start with 1, 1, 1. You kind of have to know how to start it, so that's kind of memorization. And then you add the row above. 1 plus 1 is 2. And I'm putting it in between the two numbers I added. Okay. There's no more numbers to add in that row. So I know I'm done with that row. I put 1s on the outside. Uh-huh. Wait, where, what? Wait, let me just finish answering her question, okay? 1 plus 2, add here. 2 plus 1, add here. See how I put the answer in between? There's nothing else to add once. 1 plus 3, 4, goes right in between the 2 I added. 3 plus 3, I'll put 6 right in between. 3 plus 1, 4. 1's on the outside. Are you seeing it now, Melda? Okay. Okay, Tyler, I'm sorry. I didn't understand what you were asking me. Where'd I get this? Here? Here? How'd I get those ones? Oh, that's this. Well, when you multiply something by 1, yeah. but you're multiplying. So like this, for example, that's 4 times 1 to the first power is 1 times x to the third power. What does that equal? 4x to the third. So that 1 is really irrelevant. Do you see? The one we did before, it actually added something. It changed the numbers as you went, okay? So you'll see that with 15. 15 has more going on in it, okay? Does that make sense? So look ahead to, let me just show you, if you look ahead to 15, oh, this one's going to be kind of pointless too, because there's a one there. I gave you really easy ones, I guess, because 1 to the 0, it's not going to change the whole answer. But like in this one, negative 2 to the first power is negative 2, right? Times 5, that would make a negative 10, okay? So it just depends on what you have here. You just take it slowly. You just like say, okay, what are all of those multiplied together? You know, and she actually did it in a lot of different steps, but I gave you kind of an easy one to do. But if you wanted to practice with harder ones, they're there. They're there. Okay, so here is the rest of it. I don't know how much time we have. So you have about 3 minutes, so if you want to grab your phone, of course, I just never want you to forget it. The key is on Canvas, of course, but remember you have Wednesday as well.